Welcome everyone to another interesting DSA problem which is titled as middle of the linked list. So what we are supposed to find out is that as all of you are aware how a linked list itself in its construction and all. So there is a node associated with a node. It will be pointing to another node, like that node itself will have a value and that node itself will point to another node. For example, if you look here, this is a node which has a value in it which is pointing to another node that has another value which is pointing to another node. So the constructor of the linked list itself will be having a value and a pointer that is pointing towards the next node. So what you are supposed to find out, that you have to find out the middle of the linked list, middle node of the linked list. In this case, the middle node is nothing but this 3, value 3. But whenever there is two possible middle nodes, here if you see, just by inspection also you can see that there can be possibility of two middle nodes. So in that case, return the second one. That is the problem statement. There is nothing to be done. How can we do this thing? So this problem we can approach using a technique or a strategy of slow and fast moving pointers. So I will explain you with the solution. So let's try to write the code itself. So class solution, and the method inside it define middle node. And what are things given? Head is given. What is head? Head is nothing but the starting point. Here this would be the head, this would be the head. It is a feature given in the linked list. Okay, optional list node, and you are supposed to return another node, optional list node. Okay, let's try to start. I'm going to fix two variables, two nodes. One is slow to head and fast equals to head. So what is going to happen? As you can see, initially in this condition, slow will be also here, fast will be also here. Then what I am going to do, while fast and fast dot next, whenever these both exist, this will keep on iterating. In the first case, yes, there is fast exist, and fast dot next is this 2, that also exists. In that condition, what we are going to do, we have to update the slow. Slow equals slow dot next, and fast equals fast dot next. Here fast is jumping 2 times. So in the next step, what is going to happen is that the slow will be updated one step, slow became here, and the fast will be updated 2 step, and the fast became here. And the next step also, yes, fast exists and fast dot next also exists. Then we have to again update slow to 1 point. Let's update the slow to 1 point, and fast to 2 points. Fast would become somewhere here, fast. And the question, does fast exist? Yes, fast is existing, but fast dot next is out of bounds, like it does not exist. So we cannot update the slow and fast anymore. And in that situation, in that scenario, in the event of such things, straightforward, return the slow. Right now the slow is exactly where it is meant to be. So this particular strategy of slow and fast moving pointers in the linked list will enable us to slow this problem. And what is the time complexity? Since we are just iterating through it only once, the time complexity would be order of n. Space complexity, we are not utilizing any extra space or anything, order of 1. And this is pretty much simple problem, and I hope you understood the solution and the problem statement and everything. And thank you for listening.